Well, first of all, thank you for the invitation. So we'll talk about mainly the effect of residual sedation when we start the weaning using the EDI. So I will show you some data about that. I have some conflict answers with different ranges. So what we do in our unit, we use NAVA after a failed spontaneous breathing trial. First of all, we assess readiness to wean with pressure support. And then we do a spontaneous breathing trial. If the patient fails, we go to NAVA. Otherwise, we propose the patient for extubation. In most of the data we present, it's always patient who is more than 4 days of controlled ventilation without any activity. So after that, we titrate NAVA with a specific protocols, which is something we do in the unit. It's not the point today. So what we found with this first study is that we had an increase of the EDI at the beginning of the weaning from day 1 to the day of extubation. But this one was under NAVA. You can see the first 3 days. But more interestingly, it's because between these days we decrease the NAVA level. So it can be understand that EDI is increasing. But if you look during the spontaneous breathing trial, the EDI that was recorded, we had an increase also of this EDI between the beginning and the end of the weaning. So it was not expected. We were expecting a patient having a smaller EDI because he's improving his respiratory function. But we had this from the first 3 days. And if we compare the beginning of the end of the spontaneous breathing trial, so the first failure and the first success, there was a significant difference in EDI. The EDI that was recorded during the spontaneous breathing trial, the highest EDI. That's why it's called maximum. So we did another study. We were looking at the neuroventilatory efficiency, and if you look in this data, just what happened if you are always during the spontaneous breathing trial, the first unsuccessful breath SBT and the day of successful SBT, we have no difference in the ratio between tidal volume and EDI because once again we had the same increase of the EDI with the same level of pressure support, 7 of pressure support and 0 PEEP. So the question was in this both study with more than 30 patients, why is the EDI increasing between the beginning and the end when the same level of assist is used? And the median duration of controlled ventilation when we start the weaning was 10 days. Lots of patients with pancreatitis and long stay in the ICU with controlled mechanical ventilation. So the first possible action was residual sedation, but also maybe atrophia, and we discussed that with that a little bit this morning with the diaphragm exploration with echo or whatever. So maybe we have this could explain why EDI increased, or maybe it's residual sedation. So we focused on the effect of residual sedation in patients who had some midazolam during their course under controlled mechanical ventilation. We have some data about the effect of first midazolam. Here, when it's controlled, when we use midazolam, we have some data about what happens on the respiratory pressure, esophageal and gastric, but most of the time it's in volunteers, so they are not intubated. So we see an increase of the drive and an increase of the pressure because of the airway, the increase of the airway resistance and the increase of the work of breathing. And then when you use flumazenil, you have a reversal of this effect. So it was also a way to test with flumazenil if there's still some residual sedation and what is the effect directly on the diaphragm activity. So we include 13 patients with mainly ILS due to pneumonia or pancreatitis because we have 2 different ICU, one for abdominal diseases and another one for thoracic diseases. So it was mostly at day 1 or 2 and with an average 7 days of controlled mechanical ventilation in classical level of PEEP and pressure support for our unit when we start the weaning. So patients were, each cycle were recorded and then flumazenil was injected and we were recording the EDI and the tidal volume, well, all the respiratory mechanics. So what we found is that, as expected, the effect of there are some residual sedation at the beginning of the weaning, and the effect on the EDI was an increase of 70%. So it's quite a lot, and this because these patients were on pressure support, we didn't change the level of pressure assist. We've seen an increase of the tidal volume, which was less than the increase of the EDI, and the consequence was a decrease on the neuroventilatory efficiency. But the first aim was to discuss the EDI increase under pressure support. So what we found is that it was possible to predict with EDI variation when we were reversing, when we used the flumazenil, to predict the variation in tidal volume. And it was a way to quantify the effect of residual sedation, finally, when we start the weaning on the diaphragm activation. And we didn't change, with the increase of EDI, we've seen an increase of the tidal volume, and we could, in that situation, imagine that this reversal of sedation allowed to reduce the level of pressure assist to keep the tidal volume at the same level. Because we had a wide range of EDI at day 1, from 1.8 to 59, we tried to see how the patient with different EDI at day 1, and we see that there's no correlation between this level of EDI and the level of pressure support, or even the tidal volume. So what I did is to finally see if the patient with less than 5 microvolts of EDI, if it's different from the patient who have more. And it's true that if you put a cutoff at 5, for example, it could be something different, the variation of EDI is much more higher. There's a significant difference when you use the flumazenil. So maybe, and it's also the same for the tidal volume. So the EDI could also be something that can give you some information when you start the weaning, that you still have lots of effect of sedation. You still have some residual effect of sedation. And finally, the aim was to be able to have an idea of this increase of EDI between the beginning and the end of the weaning. It can be probably in part due to the residual sedation when you use, for example, in this patient, midazolam, because it was long duration on the control mechanical ventilation. So of course there are some limits. What we knew is that when we use midazolam, we have a reduced VT and an increase of respiratory frequency with an increased work of breathing. So we quantified the direct action on the EDI of this residual sedation, and it's possible to reverse this effect with flumazenil. It's true that in this, because we monitor the tidal volume, we didn't see any sign of activation of the respiratory accessory muscle activation. We can add some increase of the tidal volume without increase of EDI, but it was not the case. You do not have any increase of inspiratory time, because under pressure support it could be a way to increase tidal volume, but it was not the case. The patient had an increase of the EDI, but also an increase of the respiratory frequency, so inspiratory time remained stable without any difference. And it's true that the difference with lots of papers were about the effect of sedation were in volunteers, so they were not intubated. And the fact that patients were intubated, we had stable resistances of the upper airway, which was the tube. So this changed the interpretation of the data, because we analyzed the effect of flumazenil without any changes of upper airway resistances. And finally, as a tool to monitor, it's possible that patients with very low EDI at the beginning of the weaning, at least in this group of patients, was more correlated to something that has to be residual sedation than a problem with over-assist or high level of pressure support. Of course, it could be a way to have an idea of when we start the weaning, if we have a patient who has more effect of residual sedation, and probably finally during the weaning, what we see is that we eliminate the residual sedation and then EDI increase, and that's why we're able to reduce NAVA level and to have the spontaneous breathing trial was successful, or at least it can participate to this increase of EDI during the weaning process according to our protocol using NAVA. So we did this study to evaluate this effect of sedation on EDI. Thank you.